So my name is Greg Michaelson. I work at DataRobot. I joined DataRobot probably around 4 years ago. It's actually the longest I've ever stayed in a job. So, you know, it's a sign of the times. I think I read somewhere that data scientists change jobs every 9 months on average. And why wouldn't you if you can just go and get a 35% bump every year for changing jobs, which you can, weirdly. So the talk today, I want to talk to you a bit about what we're seeing. So DataRobot, as you may or may not know, is an automation platform for machine learning. So if I am a data scientist or not a data scientist, the tools are being created to enable me to do my job better. And so when I joined DataRobot about 4 years ago, we had about 40 people on staff. Now we're up to like 600 or so. And what we had done was take the first 3 years of the company and about the first $30 million that we raised in capital, and we dumped 100% of it into the product. So we didn't have a website after 3 years. We didn't have a marketing team. We didn't have any salespeople. In fact, our chief revenue officer was hired about a month before I was. What we did have was a product that actually did what we claimed it did, which is surprisingly unique in the startup world. You can actually, I've learned over the last 4 years that you can evaluate the quality of a solution by the amount of services they have to sell in order to make it work, right? So turns out that's a thing. I had no idea. We thought, I guess somewhat naively, that we would just be going out and we would show people DataRobot and what it does, and we would just be taking orders, right? Like people would go, yes, that's what we need. We want it. Sign us up, right? Here's our check. Right? We really thought that's how it would go. But it turns out there are a lot of reasons why it doesn't go that way. The world does certainly seem to think that there's huge potential for machine learning and AI. And I use these slides all the time. Masayoshi-san, anybody familiar? CEO of SoftBank, runs the Vision Fund, $100 billion. I think about 50 billion of that, though, is from Saudi Arabia. So I don't know where that is. I think that was in the news recently. But anyway, those who rule data will rule the entire world. So that's obviously a ringing endorsement of the kind of work that we all do on a day-to-day basis. Gartner is certainly on board. Gartner calls automated machine learning, their name for it is augmented analytics. And so, you know, we've sort of defined that category over the last several years. AI will generate $2.9 trillion in business value and recover 6.2 billion hours of worker productivity. As a worker, you know, I pay attention when I see numbers like that. We are a startup, so it's actually in the handbook that you have to include an Elon Musk slide. Companies have to race to build AI or they'll be made uncompetitive. He pits it as organization against organization. Whoever does it best wins. Forrester does the same thing. AI-driven companies will take $1.2 trillion from competitors by 2020. I think that's certainly true. I mean, we've seen it in the financial services sector with all these little fintechs starting up, all these organizations forming to gobble up little bits of the market, little inefficiencies that the big players in the space have not been able to take care of. So user experience is kind of king, and so you see all these little startups coming in and just taking bits of the market. And that's certainly going to continue. Healthcare, insurance, finance, retail, all over the place. Even the Russians recognize that the data is important. The leaders in artificial intelligence will rule the world. That was my Russian accent. He actually said it in Russian, so there's a translation step here. But anyway, here's one. 85% of AI projects won't deliver for CIOs. That means in 20 artificial intelligence projects, only 3 will succeed. 17 will fall short. This is from Gartner. This is not super encouraging, is it? You don't have to work with organizations for very long before you realize that it's difficult to actually take an idea and convert it into a project that is actually going to generate value and revenue for the organization. And certainly, Gartner has seen that. 85% is a staggeringly high number, but I think it's relatively accurate. Why is that? There's a lot of words on this slide. I'm just going to go over them. Most organizations are still kind of learning what this is. How many of you are familiar with Alteryx, Tableau, tools like that, right? Everybody knows what these are. Their sales teams have such an easy job, right? Nobody has to go into an organization and say, you know, you really should be preparing your data, and here are all the reasons why. Or, you know, you really should be looking at reports and dashboards. Like, those could be really helpful to your business. Everybody knows this, right? And so Tableau's only job is to go in and talk to people about why Tableau is a good tool for doing that task. But if you work in the AI space, that's not your only job. We go in and we talk to organizations, and we have to convince them not only is DataRobot a good tool for machine learning, but we have to tell them what AI is, and we have to explain what the important use cases for AI are in their space, and we have to explain what are the organizational consequences for going down this path, and how much is it actually going to take from you from a commitment perspective in order to actually implement these models and do all the change management and all that kind of stuff. Most organizations have no idea. And that's another way of saying that the market is relatively immature in the AI space. And that's one of the big reasons why so many of these projects aren't successful, because organizations just don't know what it is or how they should be using it, particularly at the management level. Number two, individuals that are excited about AI are super common. They're everywhere. But organizations that actually want to take that and put it into action are very rare. We worked with a large hospital chain in Atlanta to build out some really innovative models around, they were doing some like genomic mapping and some diagnostic stuff and patient readmission, and there's mountains of use cases, huge amounts of efficiency that can be created by using AI in the healthcare space. Well, he got another offer at another hospital, and he and a couple of people on his team moved across the country, and all of a sudden you had an organization with sort of a hole and also with no champion. And so the organization was like, well, I guess we'll just kind of keep doing our thing, and their AI sort of innovation just disappeared. Because individuals that are interested in this are super common, and they can push on it if they have the political skill and the organizational capital and all that kind of stuff. But organizations that have this stuff baked into their into their DNA, are actually pretty rare. So that's another reason. Organizations that have a very narrow AI roadmap or that have a centralized data science team actually tend to want to nibble at change. Right? So if you work with an insurance company, say, they tend to do this a little bit. Right? So the pricing sort of wags the tail at an insurance group, or wags the dog at an insurance group. So, your actuaries want to build pricing, and they kind of ignore all the other places, right? Claim stuff, call center operations, there's mountains of other use cases. Kind of actually transforming the organization is pretty hard. And then the last one, and I don't want to belabor it, deploying these things is actually really hard, right? So if I build a predictive model to say, here's one, this is a really interesting one. I wasn't aware of this. How many of you have ever made a deposit at an ATM? You can do this, yeah? You could take an envelope and you put in the money, the check, and you type in, deep, 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 and you just slide it in, and there you go, deposit. Did you know that you can go to an ATM and you can put in an empty envelope and say there's money in it, and then withdraw it? It's an actual type of fraud, right? Deposit fraud. And that's why organizations have holds. So if you deposit money in an ATM, depending on your organization, you might have to wait 1 day, 3 days, 5 days, whatever, before those funds actually become available. And that's their way of fighting fraud. So one organization that we worked with decided, why can't we take the individuals, the trustworthy individuals, like everybody in this room, and give them their funds right away based on their fraud score, right? Likelihood of fraud. So set that hold dynamically based on the risk of fraud for the particular deposit. Great, super idea, right? And they actually generated millions of dollars in terms of fraud prevention from this idea. And you can't even quantify the benefit to consumers, right? Like the customer relationship experience stuff. Like, I don't know how you calculate the ROI for that. But think about the deployment. How do you make that work? All right? So I've got a network of ATMs, and they talk to my systems, and somehow I've got to inject a machine learning model into that process that is going to govern funds availability for my customers. That's going to make all your IT guys super nervous because you're monkeying with core systems. And their only job is to keep the lights on. If you break something, they're fired, right? So there's this task around taking the results and the analytics and the predictions and the AI and actually integrating it with the infrastructure and the workflows and the people and all that kind of stuff. It's a non-trivial problem. And it's not just technological, right? So imagine, so I worked with another bank that was trying to look at customer retention, actually loan prepayment. So they had this big problem where they could write lots of new loans, but these loans would refinance with competitors because of the interest rate market and all that kind of stuff. And so they were trying to identify customers that they could make a refinance offer to in order to prevent them from churning and going to a customer, to a competitor, excuse me. Well, their sales force was, I think the statistic was that 60% of them were retirement eligible. Okay? So these are very experienced people that have spent their entire careers doing relationship selling, right? Corporate banking. I know my customers. I've built relationships with them. I'm invested with them. I don't need no cotton picking machine or some Poindexter to tell me how to run my business, that kind of thing. If you take a sales team like that and you start to give them tools, customer lifetime value, propensity to buy models, next best offer models, price elasticity models, and you give them scores and tools, that's great. They can do their jobs a lot better, but it is a substantially different job. And so the change management involved in that whole process is non-trivial. And a lot of organizations underestimate what's actually required. So it's without a doubt that you can actually generate a ton of value with automation, right? So I think that's pretty well accepted. Automated machine learning is a thing, right? It even has a name, right? Augmented analytics or whatever you want to call it. Everybody's sort of pursuing the citizen data scientist. I think that's well understood in the market. You can produce faster results. Deployment is way easier technically because of APIs and how good that stuff is getting. You get all kinds of stuff for free, things like model monitoring and management, documentation automation, all kinds of stuff you get for free in this process. But the question is, where are you along this maturity curve, right? So if you look at an organization that's never done machine learning before, maybe they're over here, skeptical. Like, is this the thing? Is it just hype? I don't really know. We don't have data. Like, that's a thing. And then maybe they try something and get a ton of value, right? Like maybe they do demand forecasting, like a retailer or something like that, and generate $100 million in value, and they go, wow, there's something here. It's big. So what do? Let's go hire some data scientists, right? And so you have some PhDs that you hire, and they don't really know anything about your business because they're data scientists. They're not business people. And you try and figure it out, and you have some growing pains, right? So you got to educate them about the business, and then you got to educate yourself about what they do. You can recognize a data scientist because they can't choose appropriate footwear, and they can't maintain good eye contact. Like it's like working with them is not super easy, So there's that whole growing pain. What you end up finding is that these guys can't do everything you want, right? You run out of bandwidth before you run out of projects. That's the inevitable thing that happens. Part of that's because the list of projects is so long. Part of it's because you can't hire as many people as you want. And part of it's because your data scientists change jobs every year. And so you lose all that ability, that capability that you built up in your teams. So to go back to the story, when we first started going to market, what we went out and started saying was, you can automate machine learning. It's easy. Anybody can do it. Well, that's true. You can automate machine learning. And if you give me a week with somebody, anybody, your grandma, I can get her building predictive models productively. Guaranteed. Absolutely can do it. But if you're a data scientist and you've spent 5 years getting a PhD, and you love writing code, and you're worried about the consequences of putting modeling in the hands of people that aren't aware of all the pitfalls and difficulties and challenges, you're going to want to punch me in the nose if I say something like that. And you're going to just be glad when I leave, partly because what I'm saying is threatening, but partly because you genuinely believe that I'm introducing unnecessary risk into your organization by offering to allow people who aren't as trained and as smart as you the opportunity to build predictive models. So that talk track isn't great, right? It's not a good thing to go into a data science team and say, we can automate everything that you do. So we stopped saying that, obviously. It turns out what you need is an automation-first data science team. I was actually on a call with Gartner yesterday, and she said, the analyst I was talking to said something really interesting. She said back when self-service BI started to become a thing, right? When you were starting to build like data warehouses back, like 100 years ago, and people were starting to get access, all the DBAs and all the data people were saying the same thing. You can't give the data to the people, it will be chaos. Like, everybody will have different answers, people will be calculating things wrong, they'll be creating like cottage industries of management reporting, and certainly a lot of that happened. How many of you have access databases in your organization somewhere? It's the devil, they're the enemy. So a lot of what they said happened, but I think it would be hard to argue that the democratization of data availability was a bad thing for organizations. Certainly it created problems, but I would argue that the benefit far outweighed the cost of actually doing that. So this automation-first data science team turns out to be key, really important for figuring out how to navigate in this new space when tools are becoming smarter about the way that they actually enable people to do data science. 11:40? 11:45? Okay, right on. Perfect. All right. So, automation first means, as a data scientist, I have a backlog of use cases, right? The business has asked me for certain things that I don't have bandwidth to deliver on. Maybe I have a team of people that can work on things, maybe I don't, but it would be insane to not automate the things that can be safely automated. We maybe disagree about where the line is, what's automatable and what isn't, but if there's a line and there's stuff to the left of it, then it would be insane to not automate those things. The same argument goes for RPA, the same argument goes for data prep, and so on. There is some section of the work that data scientists do on a day-to-day basis that is ripe for automation. So if you're building a fraud model, say, fraud modeling is super important. It's key. If you can build a good fraud model, you can save millions of dollars. It's easy. There's nothing technically complex about modeling fraud. It's a vanilla classification problem in most cases. It's ripe for automation. Now, if you're building a CCAR model that the Federal Reserve is going to look at and they're going to do stress testing and they're going to analyze it and all this kind of stuff, maybe you want to have a PhD building that model, right? So you've got to be smart about how you segment the work. Okay, so how to build an automation-first data science team. There are 3, maybe 4 steps. I forgot. We'll see. We'll learn it together. Step one, everybody in your organization needs to know how to spot opportunities. So we're going to draw a Venn diagram. Here is the circle of people who understand your business. Some of them, maybe retired folks. Some of them work for you, right? Some of them are in your organization. Some of them work for competitors. Depending on the organization, some of your employees may not have any idea what you actually do. We'll hope that that's a small sliver. But maybe there's some that are justified. Here are all the data scientists in the world. Even the biggest organizations in the world that use data science deeply and heavily employ at most maybe 1,000 data scientists. I would love to see a company with 1,000 data scientists on staff. But if you look at like a Bank of America or something, some of these big Fortune 10 companies, they have hundreds of thousands of employees. Most organizations rely on that tiny little overlap in the middle there for spotting opportunities. And that's craziness. Because spotting opportunities to use machine learning is not a technical skill. All it requires is a half a day of training plus some knowledge of what you're actually trying to accomplish in the business. So you need a roadmap. You need a backlog of use cases. And the first step to getting there is to actually train everybody in your organization in how to spot those opportunities. Some of the stuff they spot is not going to be valuable. Some of the stuff they spot will. And your ability to find them hinges on their ability to spot them. Step two is create your roadmap. Here's one for banking. This is maybe the top 4 or 5 use cases in every part of kind of a global bank, right? So you've got everything from like risk management to cash management to retail banking, mortgage companies, wealth management, all this kind of stuff. And I just wrote down the top 3 or 4 or 5 use cases in every segment. If your organization doesn't have a list of stuff that you could use machine learning on, then none of this matters, right? You got to know where you're going. You need a vision for success. And so building that roadmap should be priority number 1 because there's money being left on the table every day that you don't have these solutions being built. This use case is generating at a global bank today over $300 million a year in revenue, new revenue off of optimizing fee income. I could point to all of these. This use case here, sales and prospecting, we did this with a bank who wanted to focus on one product in one business unit. They generated $10 million a year for one product for their smallest business unit. There's money being left on the table, and your ability to build this roadmap is actually key to taking advantage of it. All right, how do you create the roadmap? Number 1, you need an AI champion. This doesn't have to be an organizational position. It doesn't have to be a formally appointed person, but you need somebody who feels like they own this, right? Who can crack the whip, who can track the use cases, who can follow up with people, who can educate folks. They're going to go and have one-on-ones with people and say, hey, this is what machine learning is. This is how it works. Here's how you spot opportunities. And then they just create a big list where you put everything on there. And then there's a qualification step, and you start to winnow things down and add some project management on top of it. And all of a sudden, with one person having casual conversations with the key people in your organization, all of a sudden you can develop a roadmap that's going to generate millions of dollars in ROI, all because that person was focused on this kind of thing. I'm skipping some stuff. You need a roadmap. Step 3 is automate what you can and save your hardest problems for your smartest people. So if we look at this guy, this is how most organizations try and tackle machine learning. All right, so these bars here represent all the opportunities that you have to take advantage of AI. Most organizations take one of 3 possible approaches. So vendor models, that's the first one. I'm going to buy a fraud solution. I'm going to buy a customer churn solution. I'm going to buy, right? I'm just going to buy a turnkey solution. The second one is consultants. So I'm going to hire McKinsey to come in and build it for me. I'm going to hire PwC, whatever. And then the third one is hand coding. I'm going to go and find me a data scientist or 10, and I'm going to get them to work building these things for me. The problem is you run out of time and you run out of money before you run out of opportunities. And that's where most organizations find themselves. With automation, there are some problems that require handmade, hand-coded, bespoke solutions. There absolutely are. How many of them on your roadmap are those problems depends on your organization, depends on your data, depends on the complexity of the problem. They exist. But I would argue the number of use cases that are ripe for automation is giant. Anything in marketing, anything in forecasting, all the fraud stuff, right? Risk models. Like there are an awful lot of solutions out there that require vanilla solutions from a technical perspective. Not vanilla from a business perspective or a compliance perspective, but vanilla from a machine learning and AI perspective. And so being able to harness those things and do those first is absolutely key. And then obviously you need DataRobot. That goes without saying, of course. Okay, and then step 4. This is the last one. This goes without saying. But I wanted to put it in there because oftentimes people forget about it. You can't communicate enough about the projects that are going on in your space. One of the biggest problems that we face in trying to make customers successful is getting them visibility with the people who can actually do something with their models. There's nothing more soul-sucking as a data scientist than spending months working on a project and then not have anybody know about it and not having the political will to actually implement it and get value out of it. Over-communication is absolutely key. Whether you're automating or not, you got to talk to people about the stuff that you're doing. You almost have to be a salesman, an evangelist for the kind of stuff that's going on in your organization if you want to get value out of it. All right. This was not nearly enough time for this topic, but I will, in my last 3 minutes, open it up for some questions. Does anybody have any questions? All right. Oh, microphone. That ratchets up the stress level.
I'm curious if the DataRobot platform is particularly suitable for just supervised learning or whether you've expanded it to include unsupervised learning.
All right. Now you've done it. Unsupervised learning. Okay. We do some, right? So we do things like anomaly detection, variable reduction, PCA clustering, stuff like that. We do some of that stuff. But here's the problem with unsupervised learning. And this is not the question you asked, but it's a soapbox. So in the last 4 years, I get asked that question everywhere I go. I have never seen a value-generating application of unsupervised learning, apart from anomaly detection. I've never seen it. The problem with unsupervised learning is that it's too easy to put data into it, and it's too hard to understand the output. So for a supervised learning problem, I've got to pay up front. I've got to define the target. I've got to have labeled data. I've got to structure my data set properly. I've got to know how I'm going to use it. Supervised learning, I have to pay up front. Then I do the analysis and the predictions come out for free. With unsupervised learning, I have to pay later. I can put the data in, but then I get a mess of results that come out, and then I have to figure out what they say. Okay, I got 12 clusters. Oh, I mean 8 clusters. Oh, wait, 7 clusters. I don't really know how because nobody really knows how clustering works or how to pick the right number of clusters. Oh, and by the way, in a 50-dimensional space, I have no idea how to define what these clusters are anyway, right? And there's good stuff that you can get out of that, but it takes an awful lot of work to do it. And there's just a lot of minefields and stuff in that space. So I don't want to downplay. I do want to downplay unsupervised learning. I know people love it, and I should probably love it too. Maybe it's just I'm not educated about it, but anyway, I would love, if you know of a revenue-generating example of unsupervised learning outside of anomaly detection, I'd love to chat afterwards. I think we have time for one more.
So I just want to follow up. You mentioned prepare a roadmap and then do the easiest things first. Can you speak more to the prioritization?
Yes, I can, actually. Here are the qualities of a good use case. I skipped this slide. Number one, you have to have a clear business owner, and I'm almost done. This is just going to take a second. You have to have an owner. If you don't have somebody whose neck is on the line for the use case, don't bother doing it because you're not going to be able to implement it anyway. You need an owner. You need an owner. Number two, you have to be able to calculate ROI. Insights-only use cases are great, but if you can't draw a line to revenue, then there's a decent chance that you're wasting your time, right? Like science fair projects are super, and there are certainly some use cases where it's hard to draw a line to direct dollar impact. But all things being equal, if you can't calculate ROI, I would push it down on the list. That's not to say you can't work on it, but I push it down. Three, you need to have some sense of feasibility. Do we have the data we're going to need? Can we actually execute on the implementation? If it's not a feasible project, then maybe it shouldn't be ranked so high on the priority list. Number four, you have to have people to actually work on it. And this is related to number six. Dedicated resources are required. You can't assign somebody to spend 10% of their time working on a project and expect it to actually be successful. Side of your desk projects always fail. So you have to have dedicated resources, and you have to think about the implementation stuff up front. Because if you don't plan to actually roll these models out, you'll be one of the 17 out of 20 models that don't actually deliver because nobody thought through the whole project at the beginning. And then number five, you should pick a project with a smaller duration over a project with a longer duration. It's great to have a big bang project that's going to take 2 years to deliver, but chances are it's going to fail. If you can break that project into bite-sized pieces that you can deliver on in just a few months, then your chances of success are actually much, much higher. So these are the criteria that I use to evaluate the quality of a use case and where it should be prioritized on your roadmap. Okay, I'm out of time. Thank you guys, I appreciate it.